Hi everyone, I would like to quickly introduce myself. I'm Chang from BMMT. I will present my findings on my thesis with the title Characterization PITAYA fruit and its viscosity for green printing ink. This is a study of natural fruit as digital printing ink. My presentation today is divided into 5 main sections, which are Introduction, Literature Review, Methodology, Results, and Conclusions. First, I'm going to present the background of study. Nowadays, most documents are needed to be printed. Many industries have been paying much attention to waste cooking oil problem from household, food store, and food industry recently. Oil-based printing ink play an important role for green printing technology due to the environmental benefits such as volatile organic compound and sustainable raw material. The structural transformation of oil during cooking is same with the thermopolymerization. The next thing I will share is problem statement of this study. Regulation and requirements regulate the use of harmful organic chemicals such as volatile organic compounds in inks and dyes to prevent solvent emissions. Small changes in the impure raw material may result in different chemical and physical properties of ink that might affect the printing performance of the ink. The most important properties affect printing performance of ink is its viscosity. The main objective of my study is to select the most suitable viscosity for green printing ink. Second is to characterize the properties of green printing ink. Third is to improve the printing performance, which is the clarity of printing results and endurance of printing results of green printing ink on A4 papers. Then I will share with you literature review of this study. Printing ink fundamentally comprises a carrier medium, which are water, solvent or oil, colorant, which are pigment, dye and leads, and binder. Vehicles act as a carrier for dispersion of particles by wetting the pigments. Additive plays an important role in the ink formulation process. Colorant also can be defined as coloring substance. Pigment type colorant was selected in this project. Under pigments, there are two other types, which is organic and carbon black. Petroleum-based oil composed by 60% of mineral oil, 20% of petroleum-based resin, and 20% of fillers, which are usually pigments and adhesives, has been the source of the printing ink in the old days. Because vegetable and mineral oil-based ink show similar printing performance on coated and uncoated papers in terms of printing quality, the determinant of ink choice should be the environment and health. Volatile organic compounds are compounds of carbon except carbon monoxide, carbon dioxide, carbonic acid, metallic carbides or carbonates, and ammonium carbonates participating in atmospheric photochemical reactions. Waste cooking oil is commonly produced by cooking oil with processed plant and animal fats after frying food. Using this waste cooking oil not only prevents severe environmental pollution but also has positive effects on reducing the final printing ink cost. With rising waste frying oil content, the molecular weight and viscosity of the ink vehicles obtained increase. Fluctuation in temperature give a drastic impact on viscosity of ink. For example, a temperature increase of 5.5 degrees Celsius can reduce the viscosity of a printing ink by 50% or more. This is the Gantt chart of my study. In this session, I will show you the methodology of my study. This is the overall flowchart of my experiment. The apparatus and chemicals required for WCO filtration are waste cooking oil, cloth, stainless steel container, and gas. For methoxide preparation, we need methanol, sodium hydroxide pellet, distilled water, glass beaker, white steel, mortar and pestle. For transesterification, we need distilled water, methoxide, filter WCO, glass beaker, and heating plate. Lastly, for washing process, we need distilled water, methyl ester from transesterification, and glass jar. First, the main raw material waste cooking oil is collected. The collected waste cooking oil will undergo filtration. The top of container is covered with cloth. The oil is poured into the container. The oil is heated until all excess water evaporates. Finally, the oil is completely filtered. Second, transesterification of WCO. This is the process flow of transesterification of WCO. Before the transesterification, we need to prepare the methoxide. In methoxide preparation, first we need to smash the sodium hydroxide pellet into powder, and then 80 ml of methanol and 3.2 gram of sodium hydroxide are mixed, and the mixture is shook vigorously until fully dissolved. Lastly, the methoxide is prepared. Then, transesterification process. In this process, 40 ml of waste cooking oil is measured and heated until 60 degrees Celsius. The heated waste cooking oil is mixed with methoxide solution obtained from the previous process. The mixture is stirred and shook vigorously until both chemicals completely dissolve. The mixture is set aside for 24 hours and observed. Next is the washing process. The distilled water is mixed with methyl ester from transesterification process, and the mixture is set aside for 24 hours to react. The final product, methyl ester, is collected and kept. The last step of transesterification is varnish preparation. The mixture of BHT and WCO is heated with magnetic stirrer until fully dissolved. The methyl ester is ready to use. Third, the viscosity of methyl ester is tested. In this stage, the methyl ester undergo viscosity test to determine whether it is in acceptable range. Viscosity test of methyl ester was done by heated viscometer. The temperature of methyl ester is allowed to stabilize at 40 degrees Celsius in heated viscometer. Fourth, the natural colorant extraction from pitaya fruit, which is dragon fruit. The dragon fruit is cut. The dragon fruit is cooked at slow heat until all the excess water evaporates, and then the cooked dragon fruit is mashed. The unnecessary contaminant is eliminated and fruit extraction is kept. Lastly, the best formula of green printing ink is produced. The ink formulation with different white ratio of methyl ester, BHT, and liquid fruit extraction is tested, and the ink viscosity is analyzed. In this session, methyl ester is heated and mixed with liquid fruit extraction and BHT. The mixture will stir by magnetic stirrer, and the mixture will undergo ultrasonic bath for 1 hour. Lastly, the sample ink is produced. The table shows the white percentage of methyl ester, BHT, and liquid fruit extraction in each sample. The produced green printing ink GPI will undergo testing. Viscosity test of GPI is tested by viscometer Brookfield DV11 Plus Pro with spindle 62. The lowest viscosity of sample ink is undergo chemical bond analysis by Fourier transform infrared spectroscopy test FTIR. A drop of sample ink is tested. Lastly, printing performance test on the sample ink. The printer we use in this study is Canon Pixma MP198. First, an empty cartridge is ready. A hole is drilled on the cartridge, and then the GPI is injected into the cartridge. The hole on the cartridge is sealed. The sealed cartridge is installed to the printer. Lastly, the A4 paper is printed. Now, I will share you with my result and discussion of this study. The mean viscosity of methyl ester is 2.7 cp. The methyl ester is within acceptable range. Viscosity test is done on each sample N. The mean viscosity value for sample NA is 24.77. For sample NB is 8.01. For sample C is 50.98. The results show that the sample NB has the lowest viscosity. The comparison of FTIR spectra of commercial N and sample B is illustrated. The characteristic absorption peaks of sample B and commercial N coincident with the general evidence of triglyceride structure, presenting absorption peaks at 3,294 per centimeter with OH stretching, 1,637 per centimeter with C double bond strength, and 502 and 2.4 with C double bond twist, and 469.6 per centimeter with NH3 plus torsion mode. Visual observation is done by brush on the table. The figure shows the comparison of visual observation between day 1 and day 7. The result indicates obviously that sample NA and sample NC fade out while sample B did not fade out after 1 week. It could be concluded that sample B is the most suitable formulated N. Thus, sample B is injected into cartridge of the inkjet printer and undergo printing process. To evaluate the printing performance of efficiency, sample B is gone through visual observation on printed A4 paper. Visual observation is performed on printed A4 paper by using the sample B injected into the cartridge of inkjet printer. The inkjet sample ink will run through the system and feed cartridge. The selected image to be printed are UTM logo, FTKMP logo, starship, and words. The printing performance is shown. The printed result is in pink color as forecasted. The odor is observed during the printing process. The unpleasant smell, such as smell of musty fruit and resin oil, can narrowly to be sensed. Hence, it can be deduced that the odor problem is resolved in the ink mixture process. The formulated sample ink is left for the next day. The printing process is run again by logo, image, sheet, and words. The printing result of day 1 is shown. The outcome is identical, but the tone is different. This may be due to the purity of dye. The printing result is observed for 14 days. It could be seen that the color of printing result did not fade out. So, it can be assumed that perhaps the ink is pigment and identical to commercial ink. In conclusion, the formulated GPI with 50% of methyl ester, 5% of BHT, and 80% of natural fruit liquid extraction has the lowest value of viscosity with 8.01 cp. In spectra of FTIR, the sample ink is characterized by OH strength, C double bond strength, C double bond twist, and NH3 plus torsion mode. The final result obtained is within expectation. The color of printing result did not fade out after 14 days. In short, the goals of this study have been accomplished and the objective has been fulfilled. Lastly, I would give my recommendation for this study. The temperature of the ink was not studied, so that it could be a factor to improve whites. The number of pages can be printed by the ink cartridge is not estimated. The additive may be replaced by better improvement as well as an examination into another natural resource to create additional pigment in color. That's all for my today presentation. I sincerely appreciate your attention. Thank you.